and these objects are typically called as explicit references, right? If any object is getting created with a new keyword, and this object are typically called as explicit references, or we can say these objects, the values of the objects are referred to a variable which is called as an explicit reference. If any object is created with a new keyword and these values of these values of the objects are referred to as referred to a variable which is called as an explicit reference. So usually the explicit references, when you nullify the explicit references, it gets eligible for the garbage collection. Will get eligible for the garbage collection. So here one more important point is that even the objects that has implicit references another object, the object is still eligible for garbage collection. Let me copy this and let me create the STS. So we will discuss about this now. So I have a class, the name of the class is test. So let me have a variable of class type. The class name is test, so I'm going to have a variable as test and the reference variable is t. Right? I have a simple class, the name of the class is test. I am going to create an instance variable. This is called as instance variable. So I'm keeping it very simple for the understanding purpose. This is called as an instance variable. The value of this instance variable is reference variable is t of type test. If you want to create an object, we already know that we have to use the class name, reference variable equal to new class name. So we call it as new test. So let me create three objects, test t1, t2 and t3. So these three objects are going to have an explicit references because these objects are getting created with the help of new keyword. We will trace this program in some time. So for the understanding, if any object is getting created with a new keyword, the references are called as, the references that it is going to get is called as explicit references. And again, what do you mean by implicit references? This is also another question, implicit references. So any object that gets created from the reference variable of another object. For example, let me use this reference variable t1. With the t1, I am trying to accessing the instance variable which is t. So this t is an instance variable. So I am assigning t2 to t1.t. So I am assigning the value of t2 to t1.t. Right? So So I am doing it in a cyclic process. Here T2 dot T equal to T3. And again T3 dot T equal to T1. So this is holding a reference. I mean this we call this as a reference. Any variable that gets written in the left hand side. I mean the left hand side before the assignment operator. If any variable gets assigned before the assignment operator towards its left is called as reference, which is implicit reference. So here the implicit references are T1 dot T is an implicit reference, T2 dot T is an implicit reference, T3 dot T is an implicit reference. Here the explicit references are T1, T2, T3. So T1, T2, T3 are explicit references. If you want to talk about implicit references, it is going to be T1 dot T, T2 dot T, T3. Implicit reference variables, and these are the implicit reference values. Right? So now after this, I have created 3 objects and I have created 3 references. Right? So in order to make these objects eligible for garbage collection, I need to nullify all the 3 objects that has been created. So T1 dot T1 equal to null, and T2 equal to null, and T3 equal to null. Right? So this process is called as nullifying the reference variables. Nullifying the reference variable so that these objects will be eligible for garbage collection. So in order to place a request to the JVM to make sure it to perform the garbage collection, so we need to send a request to the JVM. To send a request to JVM, we have to use system.gc. So this line is going to perform the garbage collection. So this line is going to tell the JVM, can you please perform the garbage collection? As a developer, I have an option to request the JVM to perform the garbage collection. However, JVM may or may not accept the request. So what I am trying to say is, as a developer, I have an option to raise a request for JVM to perform what? To perform garbage collection. However, JVM may or may not accept the request. Let's trace this program and we will analyze what exactly the output is going to be, what actually happens in the memory point, from the memory point of view. I'm copying the book. So I'm pasting it here. Please focus here. So this is something very important. Today I need to make sure that you people are getting this. This is my program. Right? So let us do some tracing. So every program we all know that already. As soon as the program starts getting executed, the main thread will be created. This is something that we have been discussing for a long time. So this main thread will get access to the main method. So this is the main method, right? So first instruction will be executed inside the main method. Inside the main method, the first instruction is, we are telling the language, we are telling that please create an object, because we have used the new keyword, right? For this new keyword, an object is going to get created in the memory. So objects get created, right? So the reference variable is T1. And again, we have used 3 new keywords. So I'm directly creating 3 objects. 1, 2, right? So here if you see, is what this is T1, this is T2, and this is T3. So these objects, they always going to store what? They always going to store the instance variables. That we have only one instance variable, which is T. Only declaration part we have done. Right? So this is going to have what? This is going to have T. This is also going to have T. This is also going to have T. Right? So next what we are doing, we are after these three instructions, so these three things are happening in the system. First for first instruction, this is for second instruction, and this is for third instruction. Right? So we call this as what? We call this as explicit references, because these references are created because of the new keyword. That's why these are called as explicit references. Explicit references. Right? So now the position of the thread is going to be, the main thread will access this instruction. This instruction says let's assign t1 dot t. Let's assign t2. T2 means what? This is t2. This is t2, right? So let's assign t1 dot t. This instruction says please keep this reference to t2. Because here when you see t1 dot t, t1 dot t is nothing but it's a combination of this t1 and t, right? So t2 is t2 is pointing to this object. Indirectly this line says let's t1 dot t, let's have the value of object of t2 get assigned to t1 dot t. And again, if this next instruction is t2 dot t, we are assigning we are assigning t3 to t2 dot t. This is t3. We are assigning this to what? t2 dot t. Again, next instruction is 3t dot t. So this instruction says please use this get assignment. So these are called as implicit references, because the references are getting created without using the new keyword. Right? We have what we have done. We have ensured that t1 is assigned. We are nullifying t1 equal to null, and second we are nullifying t2 equal to null. We are nullifying t3 equal to null. So what happens? T1 is null, the reference to the T1 will be destroyed. If T2 is null, the reference to that explicit references is going to get destroyed. If all explicit references are going to get destroyed, there is no value for these implicit references. Even though the implicit references are exist here, it has no value, right? Because there should be at least one explicit references. These implicit references has no one explicit references that is already existed, because all the three explicit references are destroyed. If you see here, now we can say that all the three objects are eligible for garbage collection. If I run this code, let me run this code. Before running this code, I need to make sure that finalize method is called, so that we will get to know whether the JVM is calling the finalize method or not, whether the objects are actually getting destroyed or not. So in this I am keeping the statement out, not out of println objects. So I have called system.gc. Nothing is happening because as the JVM has an option to, as a developer, I have an option to place a request for JVM to perform garbage collection. However, JVM may or may not accept the request. So this time when it run, it has accepted the request. If I try to run the next time, so now the JVM has not accepted my request. So let me try next time. It has not accepted my request. Let me try next time. It has not accepted. Now again it is accepted. Right? It depends upon the JVM whether it is going to accept the request or not. Most of the time it will accept the request. Sometimes it will not accept the request. So now this time it has accepted only two requests. Only two objects are destroyed. It could be T1 or it could be T2. It has ignored the T3. So it did not accept the request for T3. Sometimes you may be getting only one object is getting destroyed. See, this time it has accepted only first request. Right? So this output, the sequence of output is going to give justification to this statement. What is it? As a developer, I have an option to place a request. So this is how I am placing the request to the JVM by using system.gc to perform garbage collection. However, it is up to JVM to accept my request or not. If it is accepting my request, then this finalize method will be called. So inside the finalize method, like there is a clear-cut statement which says objects destroyed. The finalize method is getting called. It means now JVM is accepting my request. This is not getting called. It means it is not accepting my request. How do I check that? By just click on run. Execute it. The second time it is accepting. Third time it is accepting only once. Fourth time, sometimes it may not accept for anything. Hope you are able to understand this logic. Try pasting the chat box. We will continue further because this is cannot stay here for a long time. We will see the finalization and we will see some JVM internal concepts. Then you will get to know about this island of isolation. You can type S in the chat box if you have understood. Shweta. Shweta. Okay.
Yes, no.
Okay.